And our next one is the velocity of the sound wave. Velocity of the sound wave. Next one, velocity of the sound wave. Velocity of the sound wave. Generally we know the velocity of the sound wave. So generally the velocity V will be taken as V equal to root of ES by P. ES, for example, yes, we are taken just only E. V equal to root of E by rho. This is not P, this is rho. Here the velocity of the sound can be measured with this formula, V equal to root of E by P, E by rho. Here E is the coefficient of elasticity, coefficient of elasticity, and rho is the density. We are taken rho or D. Why we confuse it? D. D is the density. Rho or density. E is the coefficient of elasticity and the D is the density. Coefficient of the elasticity. Next, from Newton's law, we know that density, what is meant by density? Density is nothing but a mass by volume. Next, but Newton introduced Newton's formula. Newton tells that velocity of sound in gas gives the formula Et by D. Here Et is nothing but a coefficient of isothermal coefficient. This Et is nothing but a isothermal coefficient. Isothermal means what? Isothermal process. Isothermal coefficient of a gas. Isothermal coefficient. What is meant by isothermal process? The process which is conducted at a constant temperature is nothing but a isothermal process. The process which is held at a constant temperature is nothing but a isothermal process. Newton's considering an isothermal process. In that process, the velocity of the sound E is equal to root of Et by T. It is nothing but a coefficient of isothermal coefficient of a gas. Isothermal coefficient of a gas. Isothermal coefficient of a gas. And it will be equal to pressure of the gas, root of P by D. But Newton finally concluded that the isothermal coefficient of a gas will be equal to the pressure of the gas. Isothermal means the process which is held at a constant temperature is nothing but a isothermal process. From Newton's we will get the velocity of the sound wave in gas is equal to V equal to root of P by D. This is the Newton's formula. But Laplace concluded, Laplace correction is there. But Laplace tells the velocity of sound in a gas is nothing but a V equal to root of Es by D, but that Es is equal to the gamma P by D. Here this is the Laplace correction. This is the Laplace correction. This is the Laplace correction. V equal to root of gamma P by D. Here Laplace considering Es is an adiabatic coefficient. In this case the Es is the adiabatic coefficient of the gas, volume gas. So what is meant by adiabatic process? The process which is held at a constant heat. Constant heat means the system cannot leave or enters the heat into that system is nothing but a adiabatic process. In adiabatic process there is no loss or gain of heat. That means the total heat will be constant. There is no loss or gain. There is no leave from the system or enters into the system is not done by the system is nothing but adiabatic process. The process in this process, the process which is the heat will be constant is nothing but a adiabatic process. So, in this process V equal to Laplace concluded that Es is nothing but a adiabatic coefficient of a gas and which is equal to the gamma P. Here gamma is nothing but a adiabatic constant. Gamma is nothing but a adiabatic constant and P is the pressure of the gas and D is the density of the gas. This is the sound. Next we will discuss about the topic is resonance. What is meant by resonance? Anybody knows what is meant by resonance? What is meant by resonance? Resonance means the two stationary waves. What is a stationary wave? When a sound wave enters into a or sent into a pipe, the sound wave can be reflected in opposite direction and these two waves are superimposed to each other. We will get a new wave that is nothing but a stationary wave. Now we are considering two stationary waves or two waves, two sound waves with slightly different frequencies. With slightly different frequencies can travel into a some tube. For example, we know the what is resonance and what are beats. First, resonance. First means resonance. Resonance is nothing but we are considering two frequencies, external periodic frequency and natural frequencies. So, resonance, first we will know the what is resonance. Resonance means the external periodic frequency is equal to the external periodic frequency will be equal to the natural frequency. The amplitude of the body will be increases rapidly. That phenomenon is known as the resonance. First we know the resonance. What is resonance? Resonance is nothing but the external periodic frequency is equal to the natural frequency of the body. The amplitude is increases rapidly. Due to this, the amplitude is increases rapidly is nothing but that phenomenon is known as a resonance. That is the resonance condition. And then we will discuss the beats. What is beats? What is beats? We are considering two sound waves of slightly different frequencies are travel into a pipe. These two waves are superimposed. We will get a alternate waxing and waxing. Here we will get alternate waxing is nothing but waxing and waxing is nothing but beats. Once I will repeat. Beats means the two slightly different frequency, the two waves of slightly different frequencies are entering to a pipe. These two are superimposing to each other. We will get a alternate waxing means maximum intensity or maximum amplitude. Waxing means maximum, waning means minimum. Waning means minimum. Waxing means maximum. We will get, that is, this phenomenon is known as a beats. So, once I will repeat it. First, we know the velocity of the sound wave. In this velocity of the sound wave, V equal to root of E by D. Here E is the coefficient of the gas and D is the density of the gas. But Newton tells that velocity of the gas will be equal to root of Et by D. Here Et is nothing but a thermal coefficient, thermal process and isothermal coefficient. Here Et is nothing but a isothermal coefficient of a gas and D is the density. But in this case Newton tells that Et will be equal to the pressure of the gas, then V equal to root of P by D. But Laplace correction, that process V will be equal to velocity of the sound V will be equal to root of Es by D. Here Es is nothing but a adiabatic coefficient, and that will be equal to the root of gamma p by d. Here gamma is the adiabatic constant, and then we will discuss the topic isothermal process and adiabatic process. The total in the process which is done at constant temperature is nothing but a isothermal process. The process which is held at constant heat is nothing but a adiabatic process. Any process which is at a constant temperature is the isothermal process. The process which is done at constant heat is nothing but a adiabatic process. Next we will discuss the topic is resonance. What is resonance? The external periodic frequency will be equal to the actual frequency of the body. Then that condition, the intensity, the amplitude will be raised infinitely, That phenomenon is nothing but a resonance condition. Next, beats. The two waves of slightly different frequencies are superimposed to each other. We will get a alternate waxing. Alternate waxing is produced, that is nothing but a beats. These all are the basic concepts of sound waves, and the last one is the Doppler effect, Doppler effect. Doppler effect. In this Doppler effect is nothing but the apparent change in frequency from the source to the observer is nothing but a Doppler effect. Once again I will repeat it. The apparent change in frequency from the source to the observer is nothing but a Doppler effect. Here apparent change in frequency, we are discussing about the apparent change in frequency, that is nothing but a n dash will be equal to V plus or minus V naught by V plus or minus Vs into n. This is the apparent frequency formula in Doppler effect. Here n is the actual frequency, V is the velocity of the sound wave, and V naught is the velocity of the observer. Here we have two bodies, observer, source, and Vs is the velocity of the source. So here we are considering plus V naught minus V naught, plus Vs minus Vs. So listen, we can observing a train in a station. We are reaching the train, the sound will be here large sound will be here, but we are away from the train, the sound will be decreasing. These two are the conditions, away or towards. So plus V naught is used nearer to the source, and minus V naught away from the source. Similarly, plus Vs nearer to the source and minus Vs away from the source. So here V is the velocity of the sound, V naught is the velocity of the observer, and Vs is the velocity of the source, n is the actual frequency, and n dash is the apparent frequency. Doppler effect. What is meant by Doppler effect? Doppler effect is nothing but the apparent change in frequency from source to the observer is nothing but a Doppler effect. Here we can use the formula is n dash equal to V plus or minus V naught by V plus or minus Vs into n. Here n dash is the apparent frequency, n is the actual frequency, V is the velocity of the sound, and V naught is the velocity of the observer, Vs is the velocity of the source. This is our basic points of basic or important points of our first chapter, waves and sounds. And one more thing, in this chapter we will get only long answer questions. Long answer questions means 8 marks questions only. No 2 marks questions and no 4 marks questions. In this chapter we will answer only long answer questions. We have just 5 questions, 5 long answer questions. That 5 questions will be discussed tomorrow. Today's class is over.